Black holes, the most mysterious objects in our universe. We've been studying them for years. A photo has never been taken of a supermassive black hole in history until just a few years ago. It's just too darn difficult to capture clearly. But last week, on the 12th of May, we received this image. It's known as the Sagittarius A star. Its galaxy is located in the Sagittarius constellation. My friends, this black hole is in the center of our Milky Way galaxy. And our Milky Way galaxy is about 200,000 light years in diameter. That's 200,000 years traveling at the speed of light just to cross it. The mass of the Sagittarius A black hole star is 4 million times the mass of our sun. It's about 16 million miles in diameter. If that alone doesn't blow your mind, it's also 26,000 light years away. So it takes 26,000 years just for the light to hit Earth. You can't see this with your naked eye. In fact, you would need a range of sight as large as the Earth itself. And that, my friends, is the Event Horizon Telescope. The Event Horizon Telescope is a huge telescope array consisting of a global network of radio telescopes. If you've ever seen the 1996 movie The Arrival with Charlie Sheen, he was an astronomer listening to the sky for radio waves, perhaps from other planets. He was just using one large radio telescope dish in Arizona. He discovered a signal too far away to be coming from Earth.
There's nothing more important to me right now than that. Solid spike. Nice symmetry to the modulation. Detection protocol, now!
Zane!
But shortly after he found that signal, it dissipated. After going to his boss and the authorities with his findings, they all shut him up, and the boss destroyed the evidence. Well, Zane, the character of Charlie Sheen, being as clever as he was, he knew that if he wanted to find that signal again, he would have to obtain a much larger section of space compared to the large radio telescope that he was using. He came up with a clever idea.
An array. Phased array.
He impersonated a satellite dish technician and tweaked the installed dishes to send him a radio signal with all the dishes combined.
Buenos días. Soy de su compañía de satélite local.
Can I see your dish?
He placed the dishes just a few miles in circumference within each other, making one huge radio telescope that he can monitor from his house. He wanted to prove that he wasn't crazy by finding a signal from space. The movie didn't do so well in the box office, but me as a teenager in 1996, I loved the movie. Well, this is exactly what the Event Horizon Telescope is. But instead of placing the dishes around a major city like Zane did, these telescopes are all over one side of our entire planet, making it a radio telescope as large as Earth itself. These 8 large telescopes would build a network to challenge the theory of Albert Einstein and revolutionize physics as we know it today. These 8 radio telescopes combined can see the most faintest of objects really, really far away. The bigger telescope allows us to see smaller objects, almost like zooming in with a really large camera lens. This was done to capture our first ever vibrant image of a black hole. This just happened recently in 2019. The Messier 87, or M87 as it's known. The M87 black hole is 54 million light years away, about twice the distance as Sagittarius A. You might ask, why was M87 captured first, being that it's just so much further away? You would think it would be harder to see, right? M87 is 1,000 times more massive than the black hole in the center of our galaxy. Astronomers knew where to look if we were ever going to capture a black hole as large as M87. As you can see, they seem the same size in the picture, even though it's more massive. Just like the moon looks like the size of our sun, even though the sun is 400 times larger than the moon, it's also 400 times further than the moon. It's practically a distance thing. Our entire universe can fit inside of M87. It's beyond big.
Big. Very big.
Sagittarius A star center is about the size of the orbit of Mercury around the sun. But the cool part is that even though M87 is in a whole totally different galaxy as Sagittarius A, they both have the exact characteristics as each other. They behave in the exact same way. These black holes are extremely dim. Just one telescope has to observe the image for hours just to make the mirror of the telescope absorb that much light. That way we can see it as bright as we can. And that was the most challenging part of the event horizon. They needed to have clear skies, and each and every point that they pointed their telescope all around the world. In France, Spain, Greenland, Chile, Arizona, Hawaii, Mexico, and the South Pole. Yeah, the South Pole, where temperatures can get to -80 degrees with the sunlight. But why the heck use a telescope way the heck down in the South Pole? To absorb light from images of space, you need to have a clear atmosphere without much water vapor. Water vapor actually absorbs light, so you don't want that. That's why the telescope in the South Pole is so important. The reason why the image of Sagittarius A looks blobby is because it's moving at a faster pace than M87. Its orbit is about 1 light year in just a few minutes. That's how fast it's going around. 186,000 miles per second. So the image that we see changes all the time. With such a rapid movement, the image gets fuzzy, just like your camera would if your shutter speed wasn't correct. So the M87 image is much clearer because it's moving at such a slow pace because of the size and the mass. So black holes are regions in space-time where gravity's pull is so powerful, not even light can escape. While light cannot escape a black hole, its extreme gravity warps space around it, which allows the light to bend around the black hole, making it black. So that's why in Star Trek, it's called warp drive. That's a fan pleaser. It bends space and time. So you might ask, why is the image orange or reddish? It's not that the black hole is that color at all. The real image collects light, so the image would have been a faint black and white. But the human eyes cannot see detail in a gray color spectrum. So they use a different color scheme to show and distinguish between bright light and really bright light. It's been a default color for years. A lot of astronomers use when seeing objects in radio waves. It's the same reason why James Webb has the same image color pattern, because it's taken in infrared. So will James Webb point and look at Sagittarius A at some point? I believe our scientists will. I mean, we need to, right? If the Event Horizons did, we should also do it with James Webb. Unfortunately, this image is going to look a lot worse when it comes to James Webb Space Telescope. Remember that the lens from James Webb is only about 70 feet by 46 feet, about the size of a tennis court. The Event Horizon used the size of our entire planet. The image will still look awesome though, even though it's probably going to just look like a big blob. Webb will definitely look at objects around Sagittarius A to see how the black hole is affecting things around that area. We can learn more in detail of how gravity forces work around black holes. We're pretty much rewriting our astronomy textbooks. What are you most excited about to see from James Webb? I would love to know. Let me know down in the comments below. Also, if you have any questions, let me know. Perhaps I can find the answer, or maybe I can just film another video. Don't forget to hit like on this video if you got any value, and share it with friends. Just like it's your space, it's also theirs. Thanks for watching this video. Take care, everybody. It's hot out here. I'm ready to change.